Alright, so in 4.10 we're going to talk about defining functions a little bit more. So just from 1.15 and in some other sections as well where the functions come up, I just wanted to restate the definition of a function. So it says a function is a rule that assigns a value of an independent variable to exactly one value of a dependent variable. So another way to put it is a function must match each input to one and only one output. Okay? But the opposite's not true. So you can have one output go to multiple inputs. That's okay. Okay? Alright, so if we look at these two down here, it says determine if each of the following represents a function and explain your answers. So I'm going to look at this one first, and I'm actually going to do a little bit of a diagram over here. Okay? So if we have some x values and some y values, so some inputs and some x outputs rather. So I have x values and y values. And if I look at x, it looks like I have 1, 2, and 3 as my inputs, right? So I have 1, 2, and 3 as my inputs. So those are all my inputs. And all my outputs are going to go over here. So specifically -4 and 3, right? Because we have another -4. So I'm just going to write it once. So we have -4 and 3, okay? So if we look at this, 1, 2, and 3, it looks like 1 and 3 both go to -4. And then 2 goes to 3. So the question is this a function? So if we look at this, it looks like we have 2 inputs and they both go into one output, right? So this one right here is okay because we can have that vice versa action, right? So if we reverse this statement, we can have that. So this one, the very first one, is a function. So I guess I'll just put yes up here. So we can have 2 x values go into one y value, that's fine, but we can't have the opposite of that, right? So we can't have one x value go into 2 y values, so it's kind of like splitting apart. These ones are like colliding together. So this is okay, this is still a function. But if we look at this one, if I do the same thing, we have x and y again, x and y. It looks like x I have -4 and 3, so -4 and 3, and then in y I have 1, 2, and 3. Okay? So it looks like -4 is kind of splitting out, right, to 1 and 3, since they both have the same x value. So -4 is splitting out to 1 and 3, and 3 goes to 2, right? So that's just like that middle one. So this one is not a function, because we have this x value that goes to 2 y values. So this is not a function. Okay. So that might help if we have a bunch of listed numbers, right? But what if we have something like this down here, if we have like a graph? Can we still use the same logic? Well, we can use the same logic, but I think that looking at this is going to be a lot more helpful than a table, right? So let's fill in this table really quick though. So when x is -2, what is y? Well, I'll look on my graph here. I see -2 is right here, right? So when x is -2, y is 0. When x is -3, it looks like y is maybe negative. I'm sorry. So when x is -3, it should be right here, right? So when x is -3, y should be around -6. When x is a +3, it looks like we're at 0 again. When x is 1, it looks like y is 4. When x is -1, it looks like y is 5. Okay? So just looking at the graph, and I'm just filling in the information here. Okay? So does this graph represent a function? Well, if we look at this, it looks like we have -2 and 3 going into the same y value, right? Which is okay, right? That's just like this one. That's okay. Do we have any of the same y values that go into the x value? I don't see any, so it's not like this case right here. So it looks like from the table it's a function, but is there a way that I can tell if it's a function just from the graph? Well, we use something called the vertical line test. Then I'll show you on the next page. But the vertical line test basically means if you have some vertical line and you can show that this vertical line hits 2 points anywhere across here, then it's not a function, right? But as I move my pencil, we'll just assume this is a straight line straight up and down, it only touches one single point at every point on that graph, okay? So this one right here is a function. Okay. All right, so this is a function. It passed the vertical line test, and it also passed this table test, right? Kind of like up here. All right, so let's go in depth a little bit more about what we mean with the vertical line test. So the vertical line test, it says, if no vertical line intersects the graph at more than one point, then the graph represents a function. So we have an example down here, right? So we have this straight up and down line, and it only passes 1 point, right? So this is a function at that single point, but we have to move that graph all the way across here and all the way across here, right? At every single vertical line, there's only 1 point on the graph that corresponds with that vertical line, okay? So as an example of something that does not match the vertical line test is something like this down here. So see how this vertical line straight up and down, it hits 2 points, so it does not pass the vertical line test. So this is not a function. All right, so let's use that vertical line test that we saw up here, and let's do it with these. So if I put a vertical line anywhere on this function, well, possible function, it looks like every single place that I put that vertical line, there's only 1 point. So this is a function. Okay. If I do it with this one, put a vertical line anywhere you want, it still only has 1 point. So this is a function. Right? So it doesn't matter where I put that vertical line. Every single spot, it only passes 1 point. Passes through 1 point. Okay. All right. Let's look at the next one. So this one, if I put a vertical line here, it passes through 0 points, 0 points. So what if I put it right on top of this? Well, then it hits a bunch of points, right? It's everything on that line. So this one's not a function. And maybe as a little test for you, maybe you can identify that, what equation goes to that. It should be x equals something, right? So x equals something, right? All right, so what about this one over here? Is this one a function? Well, if I put a vertical line right here, right on that line, it looks like it hits only 1 point, right? But we have to do that for everywhere, right? So what if I put one out here? Well, it's not the best vertical line, but if it was a vertical line, you see that it hits 2 points, right? It hits one up here and one up here. So this is also not a function. Okay. All right. So now that we've done that, let's look a little bit at this function down here. So we know this is a function because it passes the vertical line test, right? I can put that vertical line anywhere on this function, and I get only one point. Okay. So this is a function. It's the square root of x minus 2. So we're going to look at our graph here. And I want to know what are the allowed inputs and the possible outputs of the function. So what values can I put in for x that will give me a value for y? Well, if I look at it, it looks like these values start appearing at 2, and then they go on to infinity, right? They go on out and out and out. So my inputs here should be x needs to be greater than or equal to 2. Okay? So x needs to be greater than or equal to 2, and I'll get some output for y. Okay? All right. So that's my inputs. We also call the inputs the domain. So that's one of our keywords here, domain. Okay, and I'll show you that on the next page as well. So the domain is just all your possible x values or your inputs. And then your range is just your outputs or your y values. So what limit do we put on y, or what are our stipulations to put on y here? Well, my stipulation for y, it looks like it starts at 0, right? That's our smallest y value, right here. And it goes up to infinity as well, right? So my range is y must be greater than or equal to 0, right? Because it starts at 0 and it goes up into infinity. So that's my range or my list of outputs. Alright, so just a little bit more of a formal definition here for our range and domain. So the domain of a function is the set of allowed inputs, or just your x values. And the range is the function of a function is the set of all possible outputs, or your y values. Okay, so it says, for example, let's graph the function f of x equals x squared minus 4. So it's going to look like this. So for our domain and range, it looks like we start, for our domain, it looks like we can put anything in, right? We can put any number in for x, and we'll get some value for y. So our domain is all real numbers, so every x that we can do. And then y, it looks like it starts at -4 and goes up to infinity, right? So y has to be greater than a -4. Okay? So domain's all real numbers, and y has to be greater than or equal to -4. Right? All right, so let's find the domain and range of each of these functions. So we can do two things. So we can look at it graphically, right? So we kind of see that this line right here kind of approaches this 3 for x equals 3, but it looks like it never really hits it, right? And then same thing with this one. It goes down and all the way down, but it never really hits that 3. So why wouldn't it ever hit that 3? Well, let's look at this denominator here. If I plug in 3 for x, we get 3 minus 3, which is 0, right? And that's a problem. So my range, or my domain, my possible x values, so my domain is just x cannot equal -3. So x cannot equal, or a positive 3, right, rather. So x cannot equal 3. So that's just the equal sign with the slash, is that it cannot equal 3. Okay? So what's my values for y that I can have? Well, it looks like I'm going from -infinity all the way up, and it kind of levels out, right? Same thing for here. It goes down and kind of levels out. So my y, it looks like it's every value, but let's look at this 0 line right here. See how it kind of approaches it, but it never actually hits it? So y can never equal 0 here. So y cannot equal 0, and that's our range. Right? Because we get really, really close to 0, but we never actually get it. So y cannot equal 0, but it can equal any other value. So that's our range, as y isn't equal to 0. Alright, let's look at the next one. The next one's a little bit easier. So what's my domain here? Well, it looks like for my x values, it looks like we go from -4 right here, and it looks like we go all the way to 4, right? So my domain here is -4 is less than or equal to x, which is less than or equal to 4, right? So x just has to be between -4 and 4. Then next, I want to know my range for this function. So my range, it looks like I go from 0, and it looks like my biggest value is 4, right? So I have to have 0 is less than or equal to y, which is less than or equal to 4. Right? So y is just in between 0 and 4. Those are my values, those are my range. Okay. Alright, what about this next one? So the next one says, from the graph of the quadratic function, let's find the domain and range, identify the zeros, and locate the vertex. So let's do the domain and range first. Let's do those since we already know what those mean. So the domain is all our x values. Well, it looks like if I go, looks like my x goes this way, and it kind of goes out into infinity. So it looks like I can do all real numbers for x, right? I can plug anything in for x. So my domain is all real numbers, right? Because I can plug any number in for x. But what about for y? Well, it looks like it goes down to -infinity, right? So I can have any value for y there, but then it kind of peaks at 5 up here, right? So y has to be less than or equal to 5. So my range is y is less than or equal to 5. Okay? Alright, so that's the domain and range. Identify the zeros. So what zeros are is just where they cross this x-axis. Right? So we see one here and we see one here. So those are my zeros. and I'm just going to estimate those. But if you wanted to find those exactly, you could kind of simplify this equation, and you'll get a quadratic equation. So you can use the quadratic formula. And that's the one that we saw in the in 3.9 that I kind of gave you. So we can use the quadratic formula to eventually solve this if we simplify it a little bit. But I'm just going to estimate here. So it looks like x is about equal to 1.5 and 4.5. So that's just my x values when they cross the x-axis. So those are my zeros. And then locate the vertex. Well, the vertex is just your highest point with this one specifically. It's just where, if I draw a line straight down the middle, they just kind of mirror it, right? So this side, I can just mirror it and flip it like that, and you see the same thing on this side, right? So that's just the vertex. It's right there in the middle, okay? So what is my ordered pair for my vertex? So my vertex is equal to, it looks like 3, 5. Okay, so that's my vertex. All right. So what does the vertex of the parabola help you determine the range? Well, the y value, right, because we're looking at ranges, this y value, it's your maximum y value, or your biggest y value, okay? So that's your maximum or your biggest y value in this case, because the parabola is going down, right? If we had the parabola going up, so if we kind of like flip this, so if we have something like this, your parabola, or your vertex of your parabola, would be this right here, and that's your lowest y value, right? So it's either going to be the lowest or the highest y value, and it just depends on if your parabola is kind of going up like that, or if it's going down like in our example.